C# 9 is out, and there are a bunch of new features. But do we really need them? Just because they're new doesn't make them valuable. So in this video, we'll be looking at 5 new features. We'll identify how to use each, and then talk about where they are useful, as well as where they are not. We won't be covering records in this video because they deserve their own video, which comes out in a couple of days. Now, if this is the first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on iamtimcorey.com, and I'd encourage you to check out all the resources I have to offer. In this video, as with most of my videos, I'm going to create some source code. If you'd like a copy of my source code, use the link in the description. So let's get started looking at these new features. Now here I have Visual Studio open, and it's important to note that I have Visual Studio version 16.8.1. There's actually a minor, or actually a bug fix release that's been out since 16.8 came out. So if you go to Help, About, if yours looks similar to this 16.8.1, you'll be able to follow along. Also note that this is Visual Studio Community Edition 2019. So Community Edition is free as long as you fall into a few general categories for personal use or even small business use. So just note we'll be using Community Edition. All right, so File, let's start have a new Start window. And the first feature we're going to look at is top level calls. So I'm going to create a new project, and we'll create a console application. So console.NET Core application. And this is a C# application. If you're not filtering by C#, then you make it VB or F# and so on. So make sure you're filtering by the language you want to use at least. And I'm going to call this project name Console UI because we're going to have a couple different projects in this solution. So the solution name will be new.NET features. Or let's actually say new C# features to be clear here. Because these are C# 9 features. These are features of the language itself. There's also .NET 5 features, which are something different. It's a little confusing sometimes, but the language is C#, and we can use different IDEs to work with the language, including just a text editor. But then there's .NET, which is kind of the underlying frameworks, and that usually entails things like templates and so on. And we'll look at some of those features later on in a couple more days at least. If you get confused which one is a C# 9 feature versus a .NET 5 feature versus a Visual Studio 16.8 feature, don't worry, you're not alone. It's okay. It's not the end of the world to make sure you know which, when it comes in, just make sure that you get this feature. So with that, let's hit create and let's talk about these top level calls. So in a console application, we have a bit of ceremony around starting a console. And if you're familiar with consoles at all, and you should be if you've worked with C# at all, then you know that the compiler looks for, when it creates the executable file, it looks for this class program and it looks for static void main. And this is the entry point for your application. This is where your application starts. In fact, this curly brace is the start of your code, and this curly brace right here indicates the application is done, and it closes the application. But if you notice, we have 12 lines of code for 1 line of actual code. And before we go any further, I do want to point out this cool little addition right here where it says value : this is something new in Visual Studio. It's not part of C# 9, it's part of Visual Studio in this version. I'm not going to keep saying 16.8, but it's in there. So I do want to point this out because I think this is helpful. This is an inline hint. Let me create one more method. Trust me, this is relevant to the whole thing, but I'm going to say private static void add int x int y and we're going to say return x plus y. Really simple addition method, right? Well, we can make a call here. Whoops, not static void int, and they should be doubles. That's what I get for going fast, right? So static void double, it's going to return a double. It's going to add two doubles together. So if I said, let's just do a console write line. Let's just call the add method and say 4 and 3. Well, now it shows me that this 4 is the x value and the y is 3. So that shows what the parameter names are. It's a little hint that is just kind of bonus. How does this do this? How do we get this feature? Because if you're doing it, you probably don't see it in your copy of Visual Studio. So I do want to point out, there's a lot of little things that have been added recently. And so as, I don't want to create a whole video around just this, but I'll point these out as we go. So go to Tools, Options. Now options in here is a ton of great stuff that you can use. Now I just collapsed down environment because we actually want to go to the text editor, which is right down here, and find your language. In this case, we're working in C#. Notice all the languages that are in here, really cool stuff you can do with all of those. But in C# under Advanced, and in here, if you scroll down, there's going to be a display inline parameter name hints. That's this right here. This is experimental, so this is something that is just barely in Visual Studio. You have to enable it if you want to see it. But with this, we now get these really cool hints that allow us to see, hey, what was that parameter name? Oh, that's the x parameter. Because we have two numbers here. If you have that turned off, then you see add 4 and 3, and you don't know is 4 the x or is 4 the y. And now x and y aren't terribly descriptive, but if we had better names, we'd see better parameters here to kind of tell us what's going on. So really cool stuff there. But in this particular case, the first thing we're going to look at is these top level calls. So we have all this ceremony, and now we have even more ceremony, but for really 2 lines of code here and another couple lines of code here, we have 18 lines. Maybe we can do better than that. So what if we did this? What if we took away the curly braces around main and took away a static void main itself, and maybe class program as well, and maybe even namespace console UI. Got rid of the whole thing, and then got rid of these closing curly braces as well. And this is now top level code, except for the fact that it's yelling at me all over. So it's saying, hey, you can't do top level statements because they're not available in C#8. And you say, yeah, but C#9 is out. How do I apply C#9? Well, you right click on console UI and go to properties. And you see that, oh, target framework is .NET Core 3.1. Let's change that to .NET 5. Now, this is a good time to talk about .NET versus .NET Core. There's some confusion here that I want to make sure we're clear on. .NET 5 does not include .NET Framework. So .NET Framework was at 4.8. That's the last level it hit before we moved to .NET Core. We will not be including .NET Framework going forward. There is no merger of .NET Framework and .NET Core. .NET Core is the way forward. Now with .NET Core, since they're dropping .NET Framework, does not mean they stop support. They will support .NET Framework 4.8 as long as Windows is supported. But there'll be no new features. All new features in .NET will be in .NET itself. So you see Core to differentiate itself from .NET Framework, but now that moving forward, we're past Framework, we're not talking about it anymore, we're not using it with new features anymore, so now we have just .NET 5. So this is the continuation of .NET Core 3.1. It's the next iteration. They skipped 4 because they didn't want to have confusion between .NET Framework 4 and .NET 4. So they just kind of skipped that entirely. Now it's .NET 5. .NET 5 going forward will be the unified platform. Now you may have heard of MAUI. And I've even had people ask me recently, hey, you're going to show off MAUI. MAUI doesn't exist yet. MAUI will come about in .NET 6. That is next year, November 2021 is when it will be officially released. There'll be intro versions and early release versions of that coming out in a few months. But for the actual production ready stuff, not until November 2021, unless of course plans change. So the move from .NET Core 3.1 to .NET 5 is not a big deal. In a lot of cases, it's just that. I hit save, I close it, and now we're good to go. So I can clean this up a bit. Let's go ahead and delete private, and let's shift tab this to move it back to the right indentation level. And let's talk about what's happening here, because this isn't quite the same thing as what I had originally. Let's even go back to what I had. Let's see if we can, there we go. So that's the original. Let's actually, well, let's talk about the original and then let's talk about the difference. Okay, so in the original, let's see if I can get it. Actually, I can just do Control Z, right? Nope, I can't. Let's go back to the original. Let's talk what we had. So in the original, we had the static void main, and then we had a method in the same class. We can't really have that if we have a top level call. But if you know, let's take private off for a minute. If you were to cut this out and paste this right there, that works. Now, what did I just do? I just put a method inside of a method. You may say, Tim, well, how does that even work? Well, that's a local method. That's a method that only works inside of the main method. These can be useful once in a while, especially if you're going to be doing a couple of different additions in here, but you don't want to create a whole method that is externally available because it's only really for this method. That's when you might use a local method. Well, when we talk about having our top level code, we can't really have other methods inside of this file. So we really either make them local methods or put them in a different file. So the end result is getting rid of all of this and getting rid of all of this. And now we have top level code. And let's just prove that this works by running console UI, because it looks weird, right? We have hello world and 7, so it is working, but how is it working? Because there's no namespace, there's no class, there's no method. How does it know to call this? Well, what C# 9 does is it says that if you have a class file, which program.cs, this file right here, if you have a file that has top level calls, meaning there is no namespace, there is no class, there is no method, it's just code, then that is assumed to be the entry point of your application. So it's taking some of the ceremony away from creating an initial console application. Now the question may come up, yeah, but why do we need to do that? And the answer is we don't have to. You can still do the original console application with the namespace, the class, the method name. That's all cool. Do it that way. That's fine. But this way, if you want to create something quicker and easier and less ceremony and less curly braces indenting in and out, you can do it this way. Now, like I showed, this method right here looks like it might be accessible from other places. But if you notice, I had private and it yelled at me. Let's make it public. And it's going to yell at me here as well, because the modifier public is not valid for this item, because you can't have a modifier on a local method. A local method only works inside that local piece, inside that local area. So in your top level call file, you can only have the code that would go inside the static void main method. That's it, nothing else. You can have your local calls like the add method if it's only going to be inside the static void main. And you can have as much code in here as you want as long as it would normally fit inside static void main. That's it. Your using statements still work. You can still do that. You can still even reorder these things if you want, as long as they're all going to act as though they're in static void main. Now, there is an exception to that. I would encourage you not to take advantage of the exception, but the exception is if you want to put code below your top level calls. You want to say public class person model or whatever. Something like that. You can do this. That still works because your top level call is it at the top. But if you were to say, you know what, I want to move this to be above the top level call. Well, no, you can't do that. That's no longer valid code because you have non-top level calls above your top level call. So just remember, top level calls need to go at the top. So that's the top level calls. Now, there is a question that may come up that, and by the way, again, just don't put another class in here. Don't do that. Have just your one top level call be basically static void main. That's it, nothing else. But the question may come up, like it did for me, well, how does the compiler actually find this? It's probably pulling some kind of trick where it looks for program.cs, the file, right? And the answer is no, it's not. In fact, if we right click and say add new class, and let's call this demo.cs. And first of all, let's just prove, let's grab this exact same code. I'm gonna copy it, gonna paste it into demo and save it. And it says, nope, only one compilation unit can have top level statements. So we got a problem. We can't have both of these files. And I say, okay, aha, I've proven you have to have it in program.cs. Well, no, you don't, because if I right click on program.cs and I hit delete, then we're cool. It still runs. And if we execute it, we still get the hello world and 7. So it's not about which file it's in. It's not about, it's only about having top level code in one place. If the compiler finds top level code somewhere in your application, doesn't matter where it is, it's going to say, gotcha. That's the starting point of your application. So it's going to grab the top level calls until you hit something like public class person or whatever. Once it hits something like that, then it's going to stop and say, okay, now on line 10, that's the end of your application, meaning your application is now going to close. So that's how top level calls work. Let's talk about when you would use this or why even have it. And I think the biggest thing around having top level calls is just the simplicity and the removal of ceremony. And with console apps especially, we're talking about applications that might be used for things like microservices, or maybe we have 100 of these. Well, if we have a lot of these, having a lot less ceremony just makes sense. If it's only going to be a few lines of code that it's doing, then why have all this extra ceremony just because? And even if you're creating small console applications to do something, if you have everything crammed into your static void main, you probably shouldn't. But if you do, then you can eliminate a lot of those indents that you don't need. You have 3 levels of indent with namespace and class and method that you can get rid of and have 3 less curly braces to keep track of. So it makes life a little simpler. Simple is usually better when it comes to programming because simple means less things that can go wrong. Now, if you're just learning C#, I would encourage you not to go down this road yet because this doesn't really give you the picture of how a normal C# application works. You saw how it could only have one top-level call. Everywhere else has to have the namespace, the class, and the method name. So this is just a shortcut. I encourage you to learn the full way of doing things first and get used to that because that's the way you're going to do it normally. So when will you not use this? Well, notice there's no place to send in parameters. So normally in a console application, we have a place to pass in our args. So if you have a command line switch, you can pass in those command line arguments. We don't have that here. So therefore, you're missing that. If you need those, then you need the full call, not this top level code call instead. So that's one place to use it. Again, if you're a new developer, I would encourage you to go the full route instead. But otherwise, it doesn't hurt anything. And in a lot of ways, it saves some time and effort, and it makes your code simpler to read and understand. I would just make sure that if you have, class person model, that you move that into its own file. What you can do is control dot when you're on the name, then go down to rename file to person model.c. That's not right. Haha, no, let's not do that. And rename demo to person model. I think because what I did was I had a rename right there. But normally if you control dot, you can extract this into its own file. But it looks like with top level code, you can't do that. So that's just another reason why avoid using a class with top level code. Instead, right click, add class, person model, and then move your code over here, which in this case, I had no code, so I can just get rid of it here. But now I have my top level code in one file. You shouldn't call it demo. You should call it program.cs because that is the place that is universally looked at as the starting point of your application. This just proves you don't have to do it that way. But notice how clean that is now. We have one place for, I'm just going to rename this because it's driving me nuts. Program.cs, it's just the starting point of your application. But now we have just our program.cs has just top level code, a lot less ceremony. It's very, very clean. It does just what we need it to do. And in fact, we can get rid of this code here. Well, I'll leave it there for demo purposes so you can see it later. But again, remember, this is a local function. But the next one we're going to look at is going to be the next new feature of C#9, that is going to be init setters. So let's look at person model for a minute. And we're going to say, let's do int ID, and then we'll have first name and last name. So this is a typical class. This class is a model, which means essentially it's designed to carry data around together. So it carries ID, first name, and last name together in one bundle. Now, again, we're going to talk about records in the next video, and we'll talk about if this is better to be a class or a record. Hint, it's not going to be just a record normally. There's only certain times when I would convert this to a record. But in this class over here in program.cs, let's just say that we had a person model, control dot to add the using statement. Notice that we have to add a using statement for console UI. Why? Because we don't have a namespace in this top level code. So therefore, we're not even in the console UI namespace. There's no way of calling this code outside of this top level code, which of course is fine because you never call your static void main from other locations. So why does it need a namespace? So anyways, let's just say person model P equals new person model. I'm going to say that ID equals 1, first name equals Tim, and last name equals Corey. Cool. So that's my new person model. And I can use it to do things like, well, let's do console write line and say, let's do our string interpolation, which are a $ in front of the two double quotes. And we'll say hello, and we'll say p dot first name space p dot last name, and then let's put in parens or parentheses, whereas say p dot id, like so. So we'll know the ID of the person as well. And let's just run this real quick just to see what it says. It should be very clear. Hello, Tim Corey, and the ID of 1. That's our really cool application right now. But what if we wanted to protect this ID? Because, usually when you get information from a database, you have the ID number, you have the data. So let's just say you're pulling from the person table in a database. We said, okay, this is record number 1, which that's something you can't change. That's something that should be basically read only. But this data here, we could potentially update. And we could call back and do an update into our database and say, hey, the first name, it was Tim, but now it's Timothy. Perfectly acceptable normally. And you do your simulated update. But what if we said p.id equals 2? Well, that makes a different record in the database. Maybe that record's actually Sue Storm. But now, since I changed the ID, now Sue's record's going to say Timothy Corey. And that doesn't make sense. So we want a way to change this to say, hey, you can't change the ID number. Well, we do have the option of saying that ID is a private set. Cool. But then we have some problems here because we can't put that here. We can't put that here. And say, okay, well, I'll create a constructor that passes in these other parameters. That works, but what if there was a better way? Because you see, let's just say we're using Dapper to get our information from our database. We need to allow Dapper to write to all the fields, but we wouldn't want to be able to then change ID. Dapper doesn't play well with calling constructors. That's not the way it should work. So it's going to work more like this. Well, let's change now to the init property. So instead of a private set, we're going to say init. And what init means is that you can change this value, this ID value, either in a constructor or when you first create the object. Notice right here, that will allow the change of the ID. But now I cannot change it after the fact. So when I first create the record, whether it's this way or by constructor, that's fine. But after that, it's read-only. And it's read-only not only in this top-level method or a different method, it's also read-only in this class. So I can't even create a class or a method. Let's just say I said public void update ID. And in here I said, let's just pass in the ID, new ID, and I said ID equals new ID. And it goes, no, you can't do that because it's a init-only property, which means it can only be assigned in object initializer or on the this or base of an instance constructor or in the init accessor. So you can't do this here. Now you can, if I said CTOR, I can pass in, let's just say int ID, I can say ID equals ID. That works just fine because this is a constructor. It can do that. But you can't do it in another method. Once it's been set, it is now read only. That's it. That also means if you decide not to set the value, you're out of luck, because now we obviously can't do this here. If we run this, we can't change that value, so now it's 0. So that's not ideal. You need to make sure that we always set the value either in a constructor or when we create the record. But once we do that, now that is initialized and it can no longer be changed. So that's an init setter. That allows us to replace the set of a property with init instead, and now you can only access that or change that in the constructor or when the object is being initialized. Now, for me personally, that's a huge deal. I love that feature because just in IDs alone, that makes total sense for me to have that. And I will use that a lot. It's not quite the same thing as private set, which allows you to change that value as long as you're doing it inside the class. It's just, like I said, it's a read only once you've set it initially. I love that feature. I think it's going to be great. I don't see a downside to having this as an option. Now, obviously, you wouldn't want to use this all the time on every property because that would lock everything to be read only. There is an exception to that though, and we'll talk about that in the next video when we discuss records. Because records, it makes a lot more sense to use the init only for every property. And we'll talk about why that is. But this is a great new feature. I think it's going to be one that really allows you to kind of make your applications a little more secure, a little more bug proof. Bug proof being a relative term, of course, you can still introduce bugs, but it prevents more bugs and it really expresses your wishes more clearly in code rather than having some type of unwritten rule that people have to follow, because unwritten rules don't always get followed. So I really like the init property. Now there's one other, and I want to illustrate it right here. There's another feature of C# 9 that it's a quick one, but it's one that I think is, again, a quality of life thing. It makes a little more sense. You know, here, in this line right here, I have a duplication. I have person model P equals new person model. We don't have to have this duplication. Now, one option we have is to say var, because we know what type P is going to be because we're initially assigning it. And so it says, okay, it's a new person model, therefore P is, notice I mouse over and it says person model. And that's fine, but some people don't like var, and especially when you're newer, I don't either, because it's hard to read. You have to actually go over to here to find out what the type is. But this is repetition. We're saying person model and person model. And it's not a big deal if you have person model, but if you have I enumerable of person model, now it's this really long thing you've got duplicated on one line. And so if the type is readily understood, you don't have to have the type name anymore if in this case. So I can say just new. So person model equals new. Actually, no, you can't. So the reason that's yelling at me is because I'm not using constructor. I am assigning initial values. Let's do this again, where I say person model P2 equals new person model, like so. And I can even pass in values to this constructor, but now I can say equals new like that. So as you can see, that really cut down on the code I needed because it's inferring the type in the new because we've already specified the type over here. We don't have to say it again. In this way, unlike var, we see on the left what the type is. And like I said, let's just create constructors over here. So I'll create one that's empty so that my code still works from before. But now let's create another one where we pass in int ID, string first name, and string last name. Like so. We can say ID equals ID, first name equals first name, and last name equals last name. That might be a typical constructor. And again, remember, I'm still using the init property, still cool with that because this is a constructor. But over here, I could even say one, let's do two because we already have one. To Sue and Storm. And notice with my tags now, it says, oh, the ID is 2, the first name is Sue, and the last name is Corey. So it knows how to read this line, and this line doesn't have to say new person model because we said person model already. So that's just a shortening of that declaration. It makes a lot of sense as long as you know the type. If I said var here, that's not going to fly because there's no target type for new. It doesn't know what we're talking about. You have to give it the type, person model. And now it knows, oh, okay, and it does this. Now, again, like I pointed out, when I try to show you this way, you can't just delete this because that's not using the constructor. That's using the, setting the values with the curly braces. It doesn't work this way yet. So let's undo that. Now, if you still want to use the curly braces to set the values and you didn't want to use a type, what you can do is you can put your open and close parens and say use the empty constructor, but then set these values. And that does work. So typically we don't use the constructor when we're setting the values directly using the curly braces, but with this type of call without specifying the name, you have to use the the parens, even if you're using the curly braces. So that makes things a little easier and it makes things a little shorter, and yet it's still clear what we're doing here with our new. So when we use this syntax, I think all the time. I don't think there's a reason not to. I think it's kind of like var. It's another tool in our toolbox to make our lives a little easier. Whether you like the var way of doing things or whether you like to specify the full type, just because you specify the full type doesn't mean you can't get the benefits that you get with var of having a shorter call. Because now you can say the full type and then just say, yeah, create a new version of that. And it says, okay, I know what the type is. You don't need to tell me again. I already know. So that's what this is. I don't see a downside to using this. I don't think it makes the code unreadable because again, your type is right here. So you already know. The only time it might become a little unreadable is, let's just say we had something like this, person model P3. These are horrible names, by the way, but they're short. So person model P3, and then maybe even, let's go down here in our code. Just pretend for a minute this is scrolled off the page, and I say P3 equals new, like that. And it goes, cool, I can do that. That I'm not a big fan of because yes, you can do it that way, but now your code is more unreadable. You scroll down through, okay, P3. First of all, horrible name, person who did that, stop it. But then you go, what is that? Again, oh, you mouse over, go, oh, it's a person model class, gotcha. Okay, so P3 is person model, gotcha, we can keep going from there. But don't do that. If you're going to have it not be connected with the type, I would highly recommend you still say new person model and just be clear. That way it's easily identifiable as a person model. So I think that's the only time I see a real downside is when you do something like that, where you don't see the type specified on that same line. I like having the type specified here and then not having to specify again. I like that lack of repetition. I think it's easy. I think it's going to make the, make your lines shorter and yet still readable. But I don't like it when you're doing this and separating out the new down here and not specifying the type down here. So that's my personal feel. Remember, again, code is meant to be read by humans, and your code will be read more often than it's written. You write it once, you read it a lot of times. Therefore, make sure you optimize so it's readable. And that means not doing that. So I'm going to comment this out and say, don't do this. Let's capitalize T in this. Okay, and I'll uncomment that since I was saying don't do this. So you're very clear what that's about. So that is the new way of doing new, where we don't have to know what the type is since we've already specified the type on the left. Now for these next two, so those are the three covered so far. But now for the next two, and those three are top level initialization, which we're using right here, and then the init instead of set, and then finally omitting the type when you have a new if it's known what that type is. So those are the first three that kind of jumped out at me that I thought would be actually useful in a lot of situations in C#9. Now these next two I want to create a new project for. Now I want to create a new project because it's going to be a lot quicker to do than to try and build some code on the fly for you. So let's go to a new project, and we're going to create a new Blazor app. Now, really cool stuff in Blazor, and let's just call this Blazor app. I'm adding this to my solution, by the way. So we'll have two in here. We'll switch over to this being a startup project. Let's go to .NET Core 5.0. Notice the drop down here. Blazor Server app. We're not going to do authentication. We are going to do HTTPS, not Docker. Hit create. And there are some really cool things in Blazor that I'm going to cover in a whole separate video because there's a lot of cool stuff going on in Blazor that I think is really important to cover in its own video. But I want to use, and let's close all of these. I want to use Blazor because it already has some pre-built code for us to demo. So let's right click on Blazor and say that I want to set a startup project. And let's run this just to see what the basic startup project looks like. You've probably seen it already a dozen times or more if you played with Blazor at all. That's okay. I just want to point out one thing. That's fetch data. So fetch data says, okay, there's a temperature in Celsius, a temperature in Fahrenheit. I'm from the US, so I much more easily relate to Fahrenheit, even though it's a not nearly as cool system as Celsius is. But if we look here for this weather forecast, 57 degrees Fahrenheit, 14 degrees Celsius, it says it's scorching. Well, that's not true. And 24 degrees is bracing? Yes, it is. 48 degrees is scorching? No, it's not. And 105 degrees Fahrenheit, 41 degrees Celsius is not balmy. I don't like these. They don't correlate in any way to our temperatures. Now, this is just randomly assigned. In fact, we go back to counter, come back here, notice all the summaries have changed. -3 Fahrenheit or -20 Celsius is not mild. I really love hot weather. That's not mild, that's awful. That's cold, that's frigid. So these don't correspond to the temperatures in any way. In fact, if we go back here and look at our data and weather forecast service, we come down here to we get our IEnumerable, which is a new weather forecast it creates a random value for the temperature in Celsius, which then gets converted to Fahrenheit. So that Fahrenheit and Celsius values are actually in sync. So you can look at one and see what the other would be. But then the summary is a random value of one of these things up here. So it has no relation at all to our temperature. I would like to change that. So we're going to do some quick editing to this method. This method is all in line. It does all the work on the return. We're going to have to break that out. So what we're going to do is let's grab this right here. We're going to cut it out and say var results equals. And we'll come down here and we'll say return task from results, and we have our two, or actually our, like so. and then we can get rid of that close paren. So now we've broken this out into 2 steps. First, get the results, put it into a weather forecast array, which that's what this is creating right here. And then once we have that array, then return that array wrapped inside of task.from results, which what that does is it basically tricks the system into thinking that it's an asynchronous return. Now, with asynchronous, typically we return a task, and that task says, I'll let you know when the code is done working in the background. And when it's done working, it says, oh, okay, here's the results. I'm complete now. Here's the results of that call. Well, and that's where we get the weather forecast array, is that results, the task is a thing that says, hey, it's still working or it's done. Well, task.fromResults basically takes any result set, wraps it in a task that says, yeah, it's already done, and here's the results. So it kind of tricks you into thinking it's asynchronous when really it's just returning the value with a completed task. So the reason they did that is because they're simulating calling an API or something else, which you do asynchronously, and so they made it a synchronous call. But since it's just random data, there's no reason for it to be asynchronous because it's already done. Inline, it's super fast, therefore we'll just pretend it's asynchronous. So that's what they're doing here. That's the Microsoft template. We're not gonna have to get into it too much more. But I am going to change some values here. So this summary right here, we can actually drop that off of the initialization because we're gonna modify it ourselves. We're gonna create and this code is not the way I would necessarily do it going forward, but this is a demo code to show you this new features. So I'm gonna do a for each var rec in records. Oops, results. So one record in results. I call it rec just because I want to keep it short as possible. I don't want to have to go and name it something really long. So I'm going to loop through every result in the result set. Now, obviously, I could have done this all in one section, but I want to keep this code clean and separate because this is the code we're going to show off the new stuff in pattern matching. There's 2 different types of pattern matching that I want to show, and so we're going to do that in this section. So we're going to first look at pattern matching that's called relational pattern matching. This is where we have, and I'll put it in a comment right here. So relational pattern matching is the greater than, the less than, the greater than or equal to, the less than or equal to. So those are relational patterns. Now notice that we don't say equal to or greater than, because equal to or greater than would be our arrow function. So we don't do that. It's always the greater than first or the less than first and then the equal to. So these are relational patterns. How do we use this in here? Well, if I was going to loop through every result and change that summary, I would probably say if rec dot, not summary, rec dot, I'm going to deal with Fahrenheit because I know Fahrenheit a whole lot better than I know Celsius. So just bear with me if you use the Celsius, these numbers might not make sense. It's just for demo purposes. So if record dot is, let's say, less than 0, then I'm going to say rec dot summary equals well below freezing. Why? Because in Fahrenheit, 32 degrees is freezing. So 0 is 32 degrees below that freezing line. And I would keep going through this. I could say, okay, else if, and I'd keep going down all my different ways of expressing this to say my different ranges. But that's really complicated. So instead, we can say is rec.summary equals rec.summary rec.temperature_f switch. What this is going to do, and this is already built into C# before C# 9, to be able to do this type of switch statement on a pattern. But there's new patterns for this type of switch statement. So what I'm going to do is say that the value that I'm going to return from this switch statement is going to go into summary. And it's based upon degrees temperature Fahrenheit. So another way of saying this would be if I said switch on, let's just say that it was temp Fahrenheit. I can't, well, here. Let's get rid of that. Let's do it right. If I were to say switch on rec.temperature degrees Fahrenheit, and then I said, let's just say that it's 0, case 0, oops. I would say, okay, then rec.summary equals, well below freezing. Break. Like so. But that's a lot of ceremony. And it doesn't deal well with what about between, greater than 0 and less than 30, or greater than 0 and less than or equal to 32. Doesn't deal with that. So that's not the best way of doing it because it's just too much ceremony. So instead, we've got this switch statement, which is going to return a value. And it's going to return a value into summary. So we have summary equals, and this is what it's based upon. So say, okay, the temperature in Fahrenheit. And this is where relational patterns come in. If it's less than 0, do your arrow, and say well below freezing. And then we have to have some way of covering all the rest of the cases. So we have this discard pattern, the underscore, and say, if it's anything else, we'll say unknown. We just don't know. So right now I've said, hey, if the temperature is below 0, then say it's well below freezing. Otherwise, say unknown. But either way, notice I'm just saying the arrow function and I'm giving a value. That value gets put into summary. This less than sign now is a relational pattern that says, all right, you're saying the temperature in Fahrenheit is less than 0. If it's less than 0, then do this. Think of this as our nested if statements with our else ifs. So if it's less than 0, then do this. Else, this is our else right here, do this. So let's create a couple more options here where we say, you know what? Let's just do, if it's 32, we're going to say exactly freezing, comma. Notice there's not even a value in front of it because it says exactly 32. Cool, we can do that. And we can also say, you know what? If it is greater than or equal to 85, then we're going to say hot, or comma. So now there's another relational pattern, greater than or equal to. Cool, we can do that. So that's relational patterns. It allows us to basically do the equivalent of if, else, if, else, if, else. But we can do so in a very compact manner if all we're trying to do is set the value of one item, one variable. In this case, summary. But that brings up the next pattern type, which we're going to cover, the fifth thing we're going to cover in C# 9 that I really like, and that is our logical patterns. And the logical pattern matching is and, or, let's put ampersand here because that's our third value is not. So and, or, and not are our three pattern matching for logical pattern matching. Because, what are we going to do with ranges here? We don't really have a great way of doing ranges unless we have some way of just using else as our only range option. Everything else is kind of limited here. What we can do instead is say, well, if it's greater than or equal to, using our relational pattern, greater than or equal to, because we haven't included 0. Greater than or equal to 0, let's actually put a number there, 0, and less than 32. We're going to say freezing. So now we have this and here, just like you would in an if statement, but we type out and. It's not the double ampersand. And the reason why is they want to differentiate between our if statement and how we do if statements. And why that is, I'm not entirely certain, but I do like using the word and instead of the double ampersand. You still have to use the double ampersand in if statements, but this way it's very clear for our pattern matching what this is saying. If it's greater than or equal to 0 and it's less than 32. What is that it? The temperature in Fahrenheit. So now I can put a few more things in our range where we say, okay, after 32, we can say greater than or equal to, let's just do greater than 32. We already have 32, and we'll say, and less than 65 degrees is, in my mind, cool. And then if it's greater than or equal to 65 and less than 85, then again, in my mind, it's going to be warm. Cool. So now we have some different matches here, and we can say, I think this covers most of the spectrum, but maybe we could even be a little more exact. If we wanted to, we could say, hey, you know what? Let's do 32 and 112. If we wanted to, 212. We can say exactly freezing or boiling. Whoops, not and. Haha. See how it's yelling at me? Because it says that pattern is unreachable because of the fact that you can't have 32 and 212 in the same value. But if I said or. So now you probably wouldn't say this because you probably have one for freezing, one for boiling, but I'm trying to demonstrate that you can do these two values. You can use the or keyword, which allows you to have this relational pattern. This logical pattern. But now notice too that we can move all of these around because there are none that would conflict with each other. Meaning I can have this be the first one in the list if I wanted to. I can move it right up to the top. It's ugly right there, but not a problem because of the fact that it covers, even though it's going to find the first one that applies, this only applies for this range. Now, if you were to put something at the very top, let's say greater than negative 212 arrow livable. Something like that. Notice how we get these red squigglies because these aren't going to be covered because we already have covered everything. We've said, hey, if it's greater than negative 212, it's livable. But notice if it's less than 0, meaning this won't get hit unless it's negative 212 or below because we've already covered negative 211 and above. But now with these two, it says, you know what? These aren't needed. So our system is really good in making sure we don't step on each other's toes, that we don't have something that can't be reached because we have written it out of possibility. So really cool stuff with this. The editor is really good at understanding how to read all of these at design time and figure out what you need to know about them. But this is now our relational pattern. So we have our relational patterns here, and we have our logical patterns here. So let's just run this. And before we do, actually notice, you can hardly see it, but the squiggly here is under the discard character because this pattern is unreachable. It's already been handled by a previous arm of the switch statement, or it's impossible to match. Because we have greater than or equal to 85 is hot. Therefore, we can even get rid of our discard pattern because there's no need for that last case statement, that last option, which is the catch-all, because we've already caught it all. We've got less than 0, we've got greater than or equal to 85, and there's no gaps in anywhere in here. Therefore, we don't need that discard pattern. So let's run this again, and let's see if we have better values for our summaries. So you go fetch data, and now notice cool is 55, whereas 66 is starting to feel warm. 42 is cool. 125, yeah, that's hot. 127, that's hot. We can keep coming back here and see if we get different values well below freezing at -2. Yep, that's true, because -19 Celsius, in case you're wondering. We can keep coming back. You'll eventually get that exactly on freezing or boiling. Right there. Exactly freezing or boiling because we have 32 degrees. So really cool stuff you can do that. Make this summary a whole lot more understandable rather than having those random values assigned to it. We did all of that with just some pattern matching in this switch statement. I'm sorry, switch expression. That's one of those things. A switch statement is where you have switch on, some kind of value. This is a switch statement. This is a switch expression because it returns a value that we can then use. So that's the difference. Switch statement. Let's just, and this down here is a switch expression. I'm doing all this because I'm gonna be giving you the source code. It's down in the description. You can you just fill out your email address. It'll email you a copy of this source code. Yes, you are paying with your email address. I rarely email my mailing list. It's usually maybe twice a month that I'll send you an email. And just so you know, there is a sale coming up that mailing list people get. They get exclusive sales, so you might want to stay on it. But if you don't want to, no problem. Unsubscribe right away the first email you get, and no hard feelings. So, but with that source code, you'll get all of this. You can try it all out with my code, and kind of play around with this new stuff. Because I encourage you, whenever you learn something new, try it, and try it just like I've done it. I have not made a logical application that does something. That's where people get hung up a lot, as they say, well, how do I test? How do I, try out what I've learned? I don't know what to build. And the answer is you don't have to build anything. This isn't really anything. I mean, yeah, I had, something that was pre-built in the template that I could kind of take advantage of, but that's all I'm doing is just kind of taking advantage of that and doing something with it. If you want to test something else with pattern matching, you could still use the same list or create your own sample list. But those are the 5 new features of C# 9 I thought you should see. I think there's a lot of value in all of them. I do want to mention that switch statements can be really helpful in these kind of cases where it really cuts down your code. So yes, there is some value, but you're not going to use this everywhere. You're not going to see thousands of switch statements, switch expressions all over the place. But when you do need them, really, really helpful. And those patterns are important. Oh, and there's one thing I forgot. It's actually my favorite thing in C# 9. Favorite thing. I can't believe I almost forgot it. I want to say the best for last because this is, this is me being a little bit of a geek here, but I think this is the best thing to come out of C# in a long time. So let's go back to our console. Let's set it as the startup project again. And let's go back to program.cs. We have this code here. Now we have a couple different objects here. So normally what you do, you'd have code like this. If P3 is null, then console write line that says the value of P3 is not yet set. Something like that. Cool. We're kind of used to that. Well, and actually we have to assign a value to it because we haven't assigned a value. It should be null, but there we go. So if P3 is null, then we say we haven't yet assigned a value to it. And they could do an else that says, console write line. Let's actually do this hello statement, okay? Whoops. Come on, paste. There we go. So that's what we do normally. We do a null check first and say, hey, it's not yet set, and then do this. But what if we didn't want to have this section here? What if we just want to wrap this whole thing and say, hey, you know what? As long as it's not null, go ahead and print this line. Well, what we used to have to do, if we had took this out here, let's actually copy this because I want to keep this as what we used to do. Let's copy this, and let's, instead of using P3, let's use P2, which we do know is set. We don't want to have this right here, so we'd say, well, actually what you do is not equal to null. So if P2 is not equal to null, then go ahead and write out hello Sue Storm. That's kind of ugly, because we're reading it as if P2 is not null. So what if we just said not? And that doesn't work. But would we actually ever read it as P2 not null? What we would probably say is, up here we said is null. So what if we said is not null? Well, now that reads great, and my squigglies went away, because this is now a pattern. Remember, not is one of our patterns when we talked about our matching up here. So you have the ability to say not. We didn't use that down here. We could have, but we do have that option as well with our null, is not null. And I think this is awesome. So instead of saying, again, not equal to null, we can say is not null. And it reads like it's English. And so it's a whole lot easier to read our code. It's a little thing. It's a tiny, tiny little thing, but I think it's probably the best thing in C#9. The ability to say if P2 is not null. That just, for me, it makes my code so much more readable. And remember, code is meant to be read by humans, and it's going to get read a whole lot more than it's written. So to be able to say is not null just makes so much sense. So that's kind of the last thing I wanted to show you when it comes to these 5 features. Just to recap, we had the top level calls, we had init setters, we had relational patterns, we had logical patterns, we had the get rid of the new, the type after new, and using this is not null. I mean, it's part of our logical pattern, but really is for me a whole separate thing that just makes my life so much better when it comes to writing code. I'll use this all the time. So those are the 5. Like I said, we're not covering records in this video because records deserve a whole nother video. We've already gone an hour into this video, and we've got a lot to cover when it comes to records, about when to use it and when not to use them. So you'll see that in the next video. But that's it for now. Get the source code down below in the description. Get it, try it out, test out what you learned, test out how it works, see what does work, what doesn't work. Make sure you understand how to type these things out. So for me, forgetting to put the is, that's just because I'm not yet used to typing it out, and I'm also not used to replacing the not equal. But so get used to it. Get your fingers used to saying is not null. And that way, you'll be more set to use this in production and not have errors. You've already seen the errors when you create it in test. So try it all out. Let me know down in the comments what your thoughts are on these 5. And if there's anything else besides records and besides these 5 that maybe you want to see me cover for for C# 9 specifically. We'll cover a lot of stuff with .NET 5 and with Visual Studio 16.8 in the upcoming videos. There's a lot still to come. And if you want to check out the original video in this series where I talked about kind of the overview of what we'll be covering and what I won't necessarily touch on, but is in there, I want to check that out, just kind of see what my thoughts are there. So thanks for watching. And as always, I am Tim Corey.